Okay, we're going to be going into our next example, but before we do, I'm just going to do a little quick activity with you here. Imagine we have what's called a bird's eye view question. So you're looking straight down from the top onto this object right here. And this object experiences four forces. Or if you wish, this is out in the middle of space with no other forces present, and there's just these four forces, and we want to figure out which way the acceleration is going. Can you think of a strategy for how to do that? So the logic is to think about the vertical and horizontal separately. So if we look at just the horizontal forces, can you say F1 would be positive and F2 would be negative? If you add those together, you end up getting 300 newtons positive, which is to the right. And then when we take a look at the vertical, actually maybe I'll just erase these markings. If we look at just the vertical, which are these, can you say F4 would be positive, F3 would be negative going downward, and therefore the total would be 400 newtons going downward, negative 400. And then we can make a triangle and find F net. How'd you guys do? Did you think that strategy? And that's what we have right here. So the total X will be 300 newtons to the right, and the total Y will be 400 newtons going down. Then we make a triangle for that. So we add one to the tip of the other, and there's the resultant, and we find our F net. So Katoa, and then Pythag, and we're on our way. So now we've got F net, 500 newtons at 53.1 degrees kind of south of east. But how do we find the acceleration? Well, a couple of things you need to know. First, it's very straightforward to find the magnitude. Just do F net over m, and you've got the magnitude of the acceleration. But it's really important for you guys to know that whatever direction the F net is going in, acceleration must go in the exact same direction. And that's it. That's how you determine kind of the acceleration of an object. And now we're ready. Oh, wrong one. Okay. So you guys have this example where again, we have an object on a surface with basically no other forces acting on it horizontally, and we want to figure out what its acceleration is going to be. So the first thing, based on what I just showed you, the first thing we need to figure out is to find F net. So that's our first question. Let's find F net. But to do so, we need to draw a force diagram of this. I recommend you guys pause and draw a force diagram to get some practice. Okay, so here's our object. And if you guys notice, the object here has 680 gram mass. So let's make that into 0.68 kilograms just to start off with. Now here are the two forces. We have one that's going east of north. So I'm just going to draw that right onto this diagram here. That I'll do it on the tip right here. So there and there. There is north and there is east. And it's going to be 15 degrees east of north. Remember, the second letter is where you start. So starting in the north, we go 15 degrees east. That's going to look like this. And this angle right here is 15 degrees. And that would be a magnitude, we'll call this F1 of 7.2 newtons. All right, that's our first force. I'll just erase those two parts now. Now let's do the other one, which is going to go south of east. So there's east, here's south. And again, second letter is where you start. So now we're going to start east and go 22 degrees south from there. And this is your F2 of 6.4 newtons. Angle 22 degrees. All right, so it's very important that we actually draw the diagrams properly before we go any further. Get rid of the east and south now. Okay, so now we have two diagonal vectors. Hopefully your instinct is, let's find the components. So we make our triangle for the first one, north and east. So we'll call this y1, we'll call this x1. And for the other one, it's going to go to the east and to the south. There's our x2 and our y2. Now we just have to spend some time actually solving for these. Let's do it. This is the tedious part of the question. So we have x1 being equal to the hypotenuse, and because it's opposite, that would be sine, and it's going in a positive direction. And I'll do the same thing for the y. It is the hypotenuse, and this time it'll be cosine, and it'll also be in the positive direction. Let's do those first. Make sure you're in degree mode. So the first one's 1.863. Second one's 6.955. Do the same thing for the second one. So x2 will be equal to hypotenuse, adjacent, so it's going to be cos, and it's in a positive direction. And then y2 will be the hypotenuse, sine, and it'll be in a negative direction because it's going down. All right, more tedious work here. So 5.934 and negative 2.397-ish. All right, so we found all the components. And if you remember, if we're going to find F net, do you remember what we have to add together? So now, to find the x component of F net, which we could also write as F net x, we simply add up all the x's. So this becomes equal to x1 plus x2. x1 was 1.863. x2 is 5.934. So about 7.797. Similarly for the vertical. So you can use either R or F net when you describe it, your choice. So simply y1 plus y2. y1, 6.955. y2, negative 2.397. About 4.558 newtons. And you see we get a positive x, which goes to the right, and a positive y, which goes up. And because these are at 90 degrees to each other, let's make a triangle. Which color do we use? Okay, so for our triangle, we have the horizontal, which is, maybe I should move that over a little bit. Don't go too far over. So 7.797. To the tip of that, 4.558. And the resultant goes from start to finish. That is our F net at some angle theta. All right, so like I said, pretty tedious here. So F net is simply going to be the square root the sum of squares here, so 7.797 squared plus 4.558 squared. And that's about 9.0. I don't know how many sig digs we're doing. I guess it doesn't matter. This is not what we're looking for. So 9.032 newtons. And then we can do tan theta is opposite over adjacent. So about 30.3 degrees north of east. All right, well now we're ready to actually finish this question. It's a big monster. So step 2 is to find the acceleration. And again, if we want to find the magnitude, well that's easy because we just simply do F net equal to ma. So we just take the F net that we found and divide it by the mass. So F net was 9.03 divided by the mass, which is 0.68 kilograms. So, and again, I'm going to sig digs we have in this question here. It looks like 3. So I get about 13.3 meters per second squared. And the direction, if you remember, is the same as F net based on Newton's second law. So that's going to be 30.3 north of east. Woo! Okay, so when you're given this kind of a question, we're looking for acceleration in 2D. Well, it's acceleration, so you know it's F net is ma. So we've got to find F net first. And we need basically just to add by components. So we draw the components of the vectors, we find the components, we add up the x and add up the y separately, and then we solve the triangle to find F net. That's the tedious part of the question, but very important. Then to find the acceleration, we just have to remember these two facts. We do F net as ma, no one forgets that. And then remember the direction's the same as F net. And then you're done. All right, I encourage you guys to actually try a question like this inside your homework. I'll see you in the next lesson.